store data in a lot of these data stores in multiple ways by tuning different segments of it. It can handle multiple tunings on different data sets, which is quite interesting. Basically, key value stores, several will have a bucket in front of it. For example, Amazon's S3 gives you a bucket, a key value. The bucket generally is for namespacing or namespace considerations to kind of separate, give you a better way to separate things out. A lot of times there's different parameters or different properties that you can put on a bucket that kind of controls the data underneath that. Sharding is pretty easy. It's just hashes. It's pretty easy to be able to start to line up and work really well. So usually ACID compliant, but again, that's for a single commit. It's not with multiple commits. NoSQL doesn't really quite apply here. It's hard to run SQL across the hash. You can get parts of it. Pretty easy to implement. Again, it's a hash. You know how to use those. Those are pretty everyday stuff for us. So there actually is at least one project now that I know as part of Red Hat's Hibernate project to actually take Hibernate in JPA and layer that on top of a document still on the back end. It's actually quite interesting. So it gives us a familiar looking front end, but a little bit different on the back end. So Amazon has Dynamo and S3. There's actually a really good Dynamo paper out there as well. It talks a lot about one of the original implementations. It's very interesting. React is very tunable on the CAP side. They have very strong distributed and stored well. And actually has a built-in MapReduce. React is one of several that are written in Erlang. So most of these products tend to be written in either Erlang or Java. CouchDB gives us full ACID compliance and REST API. MongoDB gives us strong indexing and query support. So you notice that these different products kind of fill a particular niche depending on what our needs are, and one may fill it better than others. Voldemort, which is Java-based and has pluggable serialization. I believe, somebody correct me if I'm wrong, I believe Voldemort was from LinkedIn. And MySQL. So MySQL is a little bit of a non-docket here, but there's a number of companies that are using it in kind of this way. Facebook kind of does it. They're very big into MySQL, if you're familiar with that. And familiar with Facebook, there's at least one open source project where they're taking MySQL and stripping it down into a very purpose-built document store. But in this case, what you're doing is you're denormalizing your data, basically just doing key access, you're killing your indexes, all your tables, relationship, all your relational data, and just boiling it down to just a core so that you can get documents in and out as fast as you possibly can. So memory stores, these are really, really similar. The data models tend to be almost exactly the same. And again, when you look on the web, you'll find out that these are usually put together as the same. But the purposes tend to be quite a bit different. So the document stores tend to have a very solid on-disk representation. They want to store all the indexes in memory, but the data can live on disk just fine. It kind of focuses there. Memory stores tend to be used more for high-speed caching types of operations, where you need either a local or distributed cache. You want to be able to put the information in there and get it out as fast as you can. Partitioning can be a little bit tough in this space, but there's a lot of products that can do partitioning really well. Several of these do have an on-disk representation. Usually it's basically an append-only kind of a mode where it's kind of keeping it for backup in case that node goes down, it can come back up, and your cache has some information available, especially if you've got multi-gigabyte caches sitting in front of the database. You can have problems where you're bringing up, where a cache goes down, you're bringing it back up, and you're killing your database because it's trying to cache everything back up. So some of these products should look really familiar. One interesting one is Couchbase, which is CouchDB, and Membase are kind of combining forces together to make a really nice hybrid product. Memcached, which we use a lot of times we use Memcached in a local mode. It also has a distributed mode. Coherence, which is a commercial Oracle product, has very strong local and distributed support, very active development. Redis is actually quite interesting in this space. They build themselves more as a data structure server. So instead of just storing hashes, they're going to store sets and list sorted sets and stuff like this, so you can do different kind of set operations. You can do some more complicated types of manipulations with your data there. They also support really high-speed counters. So if you need counters, you can update 100,000 or 500,000 times a second. Redis has really good support for that. They're really nice to run. Tokyo or Kyoto Cabinet is a dispatch map implementation. InfiniSpan, which is a Red Hat project, they implemented JSR 107, which is kind of a dead spec. Mostly dead spec. There's a new spec that kind of comes out that it generally picks up where JSR 107 came out, when JSR 107 left off. Sorry. And then Scaleris was an early implementation, which they focused very much on strong consistency. So graph for triple stores, this is going to be a little bit different here. In that you have to think in terms of nodes and edges. There's not really a schema. You have nodes and you have edges. And they're put together in what's called triples. You have a subject, you have an object, in the middle you have a predicate that defines the relationship between those two things, those two objects. And a lot of times the relationships can be bidirectional, and you can hook all these nodes together, these relationships in very complicated ways. So for example, this is how Facebook knows that your friends, what friends you have in common with some other person, or, your high school buddy or whatever that got online. It's how it builds and manages all those kinds of relationships. So if you have that kind of a meeting, this is stellar. It works really well. Doesn't work very well as a general purpose data store. Again, schemaless. Nodes and edges, they generally support very fast set kinds of operations, unions and all kinds of stuff like that. But if you want to read more about some of the theory behind it, if you go to the W3C site, they've got a lot of information about this because it comes out of the semantic web area. So some of the products in this space, we have Neo4j and the Allegro Graph both, which are two of the more mature products that are in this space. So Neo4j gives you full ACID transactions, and they also have an object-oriented API. Allegro Graph gives you Sparkle reference implementation of Sparkle. Neo4j is Sparkle too as well. But it's one of these SQL-style languages that are available, but it's geared for this particular space. So it's going to feel a little bit similar, but it's going to be different in one way. Big data, which is actually generic term and a name for this particular one, uses dynamic sharding, really good dynamic sharding. Trinity is a Microsoft research project, so it's one of the few products here that now that runs on Microsoft platform is very Microsoft specific. And it still is a research project, but it's actually really very, very interesting. Infinite Graph is distributed across platform, a lot of good support there. ClockDB is kind of cool. This was another one of these company-derived products. Twitter in this case. So they have a need to do really super ultra-fast set operations against really large sets. So if you're trying to tweet somebody, they've got millions of followers, and somebody else has millions of followers, it wants to be able to find those unions and different set style operations, so it can be as efficient at sending out those tweets as possible. And so what they did is they wrote their own implementation called ClockDB and open sourced it, so it's available for everyone to use. It's not quite as good in the general sense as some of the other ones, but has a really, really good purpose there. And InfoGrid gives an object-based API along with the REST API, so you can sit down and command line with curl and kind of play with this thing if you want to test it out. So this slide I added just a few days ago, actually. I'm calling them interesting integrations. So one of the real problems with a lot of products in this space is there's not a lot of good indexing or searching support, stuff like that. So if you have a document store and you don't know the key, you can't get your value. So the problem is, how do I find keys in a general sense if I don't know them? Some of them will allow you to get all the keys for a bucket, but if you've got millions of keys in that bucket, that doesn't help you out a whole lot there, right? So a lot of these products are actually taking Lucene, which we know about as at least one of our favorite search engines that we can be able to integrate, but Lucene itself is really just an engine. It provides a ton of really cool features. Projects that are around for a long time, and for a long time there's a ton of support, there's a ton of development going on. And so two of the projects that kind of wrap this are Solar and Elasticsearch. Elasticsearch is a little bit newer of a product, but it gives you a JSON style look and feel in front of it with a REST API and a really interesting scalability model. Solar gives you a lot of the same kind of things with some XML configuration abilities. It has a web interface and a scalability model to go along with it. Solar is extremely popular because it solves some of the issues of using Lucene core, like distribution, or having a scalable model behind it. React Search actually, React being written in Erlang, they've taken the Lucene Java APIs and they're implementing them in the React core so that you can get this search ability now where you didn't have it before. And they even have the ability to run some of the Java code, for example, some of the analyzers and such directly against React. But it's not quite as far along in maturity wise. Solandra used to be called by something different name, but it is taking Lucene and putting it on a Cassandra backend to give you the distribution and distributed partitioning. CouchDB Lucene is another one of those, pretty similar. Distributed Lucene is one of the projects under the Apache Hadoop umbrella that is trying to do a similar thing and taking Lucene and putting it on Hadoop instead to give you scalability. And then Neo4j implements Lucene in its core to give you full text searching capabilities across the graph store, which can be really, really compelling. And then the last one here, I have just a couple of others that we're mentioning that we're talking about. One of them, two of them, right, I should say, Zookeeper and User have to do, their real purpose is in trying to make other applications scalable. So for example, HBase actually uses the Zookeeper APIs to be able to manage all the different nodes. So it gives you distributed logs, distributed key, or distributed logs, distributed configuration and synchronization mechanism across all the nodes there. User does something very similar, but it tries to do it in a little bit more simplified way than what Zookeeper does. And then the last one here is what I call XML DBs. I split them out a little bit differently because the products I looked at tend to be more of a single node style system instead of a more distributed system, which is one of my own requirements in kind of monumental space. But if you work with XML, these can be very, very excellent products. A lot of them have really good GUIs. You can do XPath and XQuery and all these kind of fun things to be able to visualize it and work with your data. And it's also different in the fact that an XML data store, it understands and knows and speaks and reads XML. It knows what the data is. With a document store, it doesn't care. You give me a key, it's a byte array. You give me a value, it's a byte array. And a log, it doesn't care. It doesn't know. You give me a key, I'll give you whatever this thing is back to you. The application decides what it is. So that's it for the main part of the presentation there. That's a lot of information. I'd be happy to take some questions if anybody has to kind of go through a few things at all. Yeah?
You mentioned earlier there's no access control. Could you address that a little more, how you handle that?
Sure. So, access control. Most of these systems have zero access control, so there's no account management, there's no permissions management, nothing like that at all. Anybody has free access to it. And so when you're doing development or quality assurance and stuff, that can be a big deal. So